మాట్లాడదాం. All right. Good evening, everybody. So we are back. This is our third stream, right? And we will be continuing without any further ado. Okay. So we are here. We control the number of ports opened by the operating system with monitor. So he's asking for the number of ports to be controlled. So we do not have any other option except for using the built-in semaphore. Sorry, I mean, what is that? Mutex lock, yeah. We need to use the official Mutex lock, and I don't think we have anything else. So the thing is, even though if it was asking to control the number of ports open, can't we do the Mutex lock thing with normal variables? The swap function is cause a lot of confusion. I'm just looking for demonstration, and I don't want to let this shortcut actually demonstrated will be the same the library. Code monkey. But it will be a simulation, not real synchronization. Mutex semaphore exists to solve problems. Maybe now we can use Rails, right? With variables like void work void work1. Thread full of shared variables without synchronization. Okay. 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 It is not that hard, right? Because both threads can run at the same time. Problem has a name. This is the point. mutex protects variable. Okay. Nice, right? This looks what do you call? This looks less demonish and less scary. A global variable ports and a mutex. You got the ID, and this is requesting port. We are locking the mutex. If ports is greater than 0, okay, process not port, and unlock. I understood and did not understand the logic at the same time. I just the flow for mutex spaces. Like a process is requesting port and locked, and then mutex is locked. What does it exactly do? Then you give the port to a process and then unlock. So can I imagine the if between lock and unlock as a critical section? And what else? And again, locked and unlocked. Okay. Okay. You need to lock and unlock when assigning suspending process. The mutex story. Only one thread is allowed to run this protected code. From this point, got it. When you lock it, only one thread is allowed to run. No one else is inside. Nice, nice. Thread enters immediately. Someone else is inside. Thread stops and waits. The OS pauses the threads automatically. So mutex is exclusive permission. That is the name itself, mutual exclusive lock. So your intuition is 100% correct. Everything between lock and unlock is a critical section. Okay. Okay. So there are no more. All right. Managing shared data, shared port. Read it, modify it. You must lock the mutex. Using the port, this does not touch shared data. So to not keeping the lock and block others unnecessarily. Take the port, share data, use the port, no share data, release the port, share data. Okay, this block is making entire sense now. Thread holds mutex while sleeping. Thread 1 locks mutex, thread 2 waits, thread 1 reads and decrements ports. Thread 1 unlocks mutex, thread 2 locks. Request lock, unlock, use port lock, update unlock. You request for a resource and then you lock it and then you update it and then you unlock it and then you use the port actually that is asleep and again you lock it, update it, unlock it. Right. Add conditional variable. I think this is enough for monitor. It works without conditional. Menu told just because process is waiting in systematic execution, so it might not forever. What is the problem? Solved in the above code. Both statements can be true at the same time. And the mutex only code process do not wait at all. Okay, we will think about that one later. I mean, this is more than enough. We will get this code to working. Ouch. We will get this code to working. Ports is a shared variable. So you just need to log the critical section. Semaphores. This is what all we did today. Should we use another row? Yeah, I think. What do you think? Monitors. What will we do? Have ports and pthread mutex t mutex. Let's have this and have the work function and have the ID and requesting port. ID is requesting port. Flush standard out. Pthread mutex locket. Mutex. Let's lock it. And if ports are greater than 0, right, ports minus minus decrementing process got port, flush it, unlock, sleep, actual process, and then again lock it, increment, release port and flush it, unlock it. Since you are making, this is important because you are modifying mutex. That's it. Initialize pthread mutex init. It takes mutex and null. Create join and end it. Creating takes 4 parameters as you thought. You will give the thread ID, you will give the null, and you will give the work, and you will give the ID of the process. You can give the PID if you want though. This is enough because I'm not thinking of becoming an OS programmer in the future. My goals are different, so I think this level of understanding is enough. Where did experiment 4.1? Let's open experiment 4.2. Uni STD. And what do we need? Thread, since we are dealing with threads. And then you need to initialize this mutex underscore t mutex, and you need int port is equals to 1. I'm trying to do this without saying, by the way. Alright, let's do this. Void star work void arg get the port int id is equals to dereferencing it, dereferencing the argument. Now you got the id, and what will you do after the id? After you got the id, the locking and unlocking are inside the mutex. So printf process personality is waiting time for port. What is that id? And you will lock it. Person mutex, you locked it, and if port is greater than 0, that means port is available. You will port minus minus, and process personality is accessing port id. F flush standard out, and now I will be unlocking the mutex. And then we will be sleeping for 2 seconds. This is actual accessing, actual using. And again, you will lock it. You will lock it, and you will increment the port. Process dialing is completed. F flush and we will unlock it. Is that it? You locked it, you made it to work, and you unlocked it, and now I don't know though, but I'll try. And inside the main, what will you do? You will create threads. P. Okay. P thread, right? P thread T. T1. T2. Let's do that. Int A is equals to 1. B is equals to 2. And now what will they do is P thread underscore create T. Okay, first you need to initialize the mutex. You are initializing the mutex. Okay, I need to look at the syntax over here. Let's see, ID is requesting flush it. Locked the mutex if port is greater than 0, decrement it. Process got port and flush it. Okay, wait. We did good. Trust me. Requesting yeah, it is. It requested and it got port and we unlocked it and we select and we logged it again and we implemented it. P thread mutex in it, that's correct. And it will take null as the default value. And now create P thread underscore create. I really hope that is the case. This is becoming a variable. I mean a data type, that's what I meant. Ampersand T1 and null is a default data type. And work function and ampersand A thread create ampersand T2 null work ampersand B. And after creating, you need to join. T2 is enough. That is a function call, okay. I think that's it. I don't know, let's see. Four point two point three. What is going to be 4.2? Expected identifier. Mutex undeclared. There might be a spelling mistake. Expected identifier mutex thread underscore t. Is it not the case? Pthread mutex underscore t is equals to mutex. Let's check. Wait, I didn't even notice it. Is it not pthread underscore t is equal to mutex? I thought it's oh my god, how do you initialize, how do you declare int here, right? Similarly, pthread mutex underscore t thread or mutex, whatever it is literally the same. Oh my god, good. Silly mistakes. Nice. Oh my god. We just need an ampersand. Nano experiment 4.2.3. Let's recompile it. Why did not I get process 2 got port? Because process 2 never waited. When it checked, the port was on. Oh my god. Greater than 0, decrements port. Now port is equal to 0. Unlocks mutex. Uses port. Releases port later. So far all good. Requires support. Locks mutex. Does not enter the if. Unlocks mutex. Prints completed. So process 2 never got port. Mutex protects correctness. Mutex does not guarantee progress. No two processes take the port together. It does not ensure everyone eventually gets a port. That's why process 2 just exists. No race conditions of access. Waiting. Yeah. Semaphore. Why semaphore version has no memory of waiting processes? Mutual exclusion is not equal synchronization. Since we implemented mutex lock, semaphore should be easy now. At least I hope that is going to be the case. Okay. Let's rename as day 5 of SD. Okay, I don't want that here. Don't absolutely. Obviously, CPU is throttling, and memory too. That is understandable. Wow, I didn't expect it to be this long. So in our fail lost proper monitor. Mutual exclusion. If resource is unavailable, process must wait. Not exit, not spin. When resource becomes available, a waiting process must be woken up. Mutex only got solved once. Semaphore solved 1, 2, 3. Now monitor must solve 1, 2, 3 using mutex and conditional variable. Shared resource. Mutex protects shared data. Pthread conditional thread. Cond for waiting and signaling. So it is kind of like wait and post. Thread function, okay. Process trying to use the port. Enter monitor. Wait until condition is true. Okay, it is kind of understandable now. Conditional wait. Nice. Condition is satisfied. Process got port and flush it. And exit monitor. Nice, nice. Enter monitor again. Increment it. Releasing the port. conditional signal, it waits the condition for mutex and it signals the mute. Okay. Before implementing monitor, you should be able to implement a mutex lock and after that a conditional lock. We just implemented mutex that alone is not enough for monitor. We need a conditional variable too. Okay, man. Concurrent execution. I think if you know this should be easy. This should be easy too. You already dealt with semaphores. Fixed partition. This should be like DS. This should be like DS2. Banker Salgaradamaha. Yo, I am having a feeling like this should be completed. This can be completed today. Let's get a bit of motivation. And we have DBMS next, right? I feel like this is more going to be like FSD. 15 experiments. Write a Java program that connects databases and databases. I think we should do this as well. Everything yesterday. Frames and okay. Wow, if we are able to complete these labs, then we can chill for the next 4 months. Trust me. Surely I should be doing this Python programming. See, again we have this, the JDBC. See, threads, they are here. I don't think we'll be using Java. We should do this, man. This is like a regret for me. So we should be able to implement this ADS. And that's it. We will do ADS later. I mean, after when we get into the job things. But now, let's complete this. I can feel leveling up, dude. I don't know if you can understand it or not. But I can see the progress. And I am happy about it. We need a conditional variable too. Just mutex lock. with does this. If a thread has no resources, team it skips. Oh god. Oh god. It skips instead of waiting. We don't want to busy waste CPU. So use a command that wait and notifies when we are we have resources available. This is enough. Yeah, this is enough. So shall we start writing? I think we should, yeah. Let's change color, shall we? Let's use a lighter color. What color do we use, people? Custom. Yeah, that seems good. Kind of like a cream white. So everything is mostly same. Lock it. Right. Between the lock and unlock. Between inside the first critical section. Inside first critical section. Inside first critical section between lock and unlock. While port is equals to 0, print waiting, flush it, pthread, conditional wait, we are going to make the mutex, sorry, the first parameter is going to be conditional. That's what I'm thinking. Condition and mutex. And not if, because if just checks, if works only once. Then decrement port, process got port. Flush it. inside the second critical section, p-thread conditional signal, that is a function. So we have p-thread t, just a review. We have p-thread underscore t, we have p-thread underscore mutex t, we have p-thread underscore condition t, and we have p-thread underscore mutex init, don't we? Yes, we have p-thread condition init, we have p-thread mutex lock, we have p-thread mutex unlock, oh my god, we have p-thread condition wait, and we have p-thread condition signal, yeah, and we have p-thread create, and we have p-thread join. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You got 10 variables plus functions combined regarding the p-threads alone. And if you understand this, and I'm not even including the semaphores. You have sem underscore t semaphore thread, and you have sem underscore I don't know. There are two more. Let's give it to ChatGPT. No, it is not working. Okay, it is having problems. Let me see. Rectangle. Noise kernel. Networking system. Nice. Wow. All right. We are doing everything except doing OS. Anyone's here? It's already been an hour. And we are still at monitors. Oh my god. Yeah, yes, it is necessary. So let's write this. Experiment 4.2, we will replace it. Shall we write it again? Yeah, I think we need to write it again. Oh shit. You can't delete completely? Let's do, yeah. RM experiment 4.2.3. Nano experiment 4. Alright. Everything is mostly same. Okay. Hash include std.h. Hash include instance.h. Hash include unism.h. Void work void art int id is equals to int r. We got the id inside. All right. You need to declare some global variables, right? Yeah. Right. Port and port, it is a shared resource, and page_right underscore mutex underscore t mutex page_right underscore con underscore t cond, and that semicolon costs a lot. Now what are you doing? You will print waiting or requesting thread personally is requesting for port ID, and let us enter the critical section now. Page_right underscore mutex underscore lock. We are going to lock this. We will have condition. What is the condition? While port is equals to 0, that means port is busy. And now you need to printf waiting thread Sunday is waiting for port. Okay, wait. Why is it you wrote requesting? Okay. If it is not waiting, then it accessed. It is requesting, it is waiting. Yeah, requesting and waiting are not the same, don't worry. And after waiting, what will you do? We need to execute the condition here. Oh, first we need to flush it. Obviously, you will make the condition wait for the mutex. Nice, and if port is not 0, that means you can printf thread T accessed got port ID. Now let us unlock it. Not if, because if works only once while we did it. And now we are missing something here. Flush it. There is a logic blur. Requesting port. Okay. We flushed it. Okay, we need to flush it as well. Mutex locked. And if while okay. It got port and flush it. Oh, you did not flush anything. Okay, you messed up the logic. It requested and flushed it and we logged it and we are waiting and we made it to wait conditionally, yeah. And okay, before getting we need to decrement. Yeah, I mean obviously port minus minus, because if it is not waiting it got the port inside the critical section. And now you unlocked the mutex. Now it is the unshared resource. Okay, sleep for 2 seconds. And now log it again. Pthread underscore mutex underscore lock. What do you need to lock? Mutex. We locked the mutex and what do we do now? We increment the port and because it is free now and we release. Was released from port and and you made it wait and now signal it. After releasing you are supposed to flash it, yeah. Now we are unlocking it. Okay. Everything's blurry. Create threads. Created threads and we created IDs. Okay, we need to initialize. New text initialize. Capable. No. Now what? We create. We create a thread and now we are referring to work. We will create thread 2. Now we are joining everything. That's it. It's pay thread. Got it. Passing argument 1, conditional length. From incompatible pointer. How do you initialize the mutex? Let's check out. Right. Thread got port and you need to flush it as well. You messed up 2 flushes and unlocked. And we slept for 2 minutes and port incremented port and thread released from port. Okay, we flushed it and mutex. Everything is working good in this. That is true though. And what now? Pthread underscore. Okay, you need to give condition, not mutex. After every print, flush. And we flushed here. Pthread join. Okay, join does not take references. Yep, that is true. Don't forget a goddamn backslash in. Nice, man. Nice. Real monitor. There used to be, this one above somewhere. Yeah, here. Phase 1, take the port, use the port, release the port. I think I need to write this one. The basic idea. Yeah, it is worth implementing. I mean, it is worth investing the time. Take the port, share data, it take pthread. Alright, so pthread, we are locking it. No, why writing all of that? Instead, we will write make process wait here, yeah. This one, yeah, this one. While ports is equals to 0, pthread conditional wait. Give the port minus minus and phase 2 using port unshared data. Phase 3 releasing port. Again, this is shared data. I don't think textbooks are going to give you this. Here, lock and unlock. Release port plus plus. This is a basic idea, and we completed it. Congratulations to me. 1 hour 30 minutes, and now is this the same as the previous experiments? I'm having the feeling we already implemented it. The semaphores are hard, I don't know. Only about concurrency. Nice concurrency. We will do that. I want to get some progress. Producer, consumer. Yeah, 128. It is already 8 p.m. People, buffer limited size. Puts item into the buffer. Consumer removes items into the buffer. Producer must wait. If the buffer is full, consumer must wait. If buffer is empty, producer and consumer must not access buffer at the same time. Classic synchronization problem. Empty semaphore, full semaphore, mutex semaphore. Full, nothing is produced yet. Mutex, this is a binary semaphore. Wait if buffer full. Wait if buffer is full. Enter critical section, produce item. Signal mutex, exit critical section. Item available. Nice. Wait if it is full. Enter critical section, consume item. Exit critical section. Signals not available. Wow. Trust me, I kind of understood the flow. Okay, this is producer. Alright. Semaphore in STD size 5. Buffer of size in is equal to 0, out is equal to 0. Semaphore, empty semaphore, full semaphore, mutex semaphore. So item is equals to 1, while item is less than or is equals to 10. Okay, wait for empty slot. Enter the critical section. Buffer in. Item. Producer produced item. Flush it. In is equals to in plus 1 mod size. Why is mod size? Okay. Sim post. Mutex. Sim post. Full. Sleep. And increment the item. Nice. Consumer int item. Consumer takes every time. Producer produces only 10 items. Consumer consumes all the times. It is waiting for item. No. Consumer waits. Wait for empty slot. Okay. Okay, people. It is 1 hour 30 minutes. I will eat and I will come back. This one will be done easily and this one will be done. We will read, this one too. Producer consumer. A list of memory blocks, a list of processes. Memories are undivided. Allocate the process to the first block that is big enough. Allocate the process to the smallest block that is big enough. Allocate the block to the largest block. Please, what? These are blocks. These are processes. Nothing is allocated. Yo, I think I can do this. Bayesian Banker's algorithm. 3 more experiments, alright. So I will come back after 30 minutes or something, and I'm really loving this.